All right, guys, here's your notes for section 3.1. I think this one's going to go pretty quickly, especially since only 7 of you guys sent me this information, so that's going to be a pretty small data set. Anyway, here we go. Everything we've studied so far in this class has to do with univariate data. What does that mean? It just means one set of data, like GPA scores or something like that. Well, now we move on to bivariate data. That means that I have 2 sets of quantitative numbers. Here's our first definition. A response variable measures the outcome of a study, whereas an explanatory variable may help explain or influence the values of the response variable. Look, if I give you 2 variables, I'm going to ask you to pick one as the explanatory variable and one as the response variable. So I use this example a lot, GPA and IQ scores. If you were going to pick one of those 2 things, your GPA as a student or your IQ score, a measure of your intelligence, as one that would help predict the value of the other one, I think we would want to call this the explanatory variable, because if I know that you have an IQ score, I'm willing to guess that you're going to have a higher GPA. Or if someone has a smaller IQ, that they're going to have a smaller GPA. So I would call this the explanatory variable and this the response variable. The response variable measuring the outcome of a study, how did education go, whereas explanatory variable may help explain or influence the values of the response variable. Okay, so there's the idea. Our data gathering example for this section was me trying to get you guys to tell me shoe size and how many steps it takes you to walk from here to there, basically, in the hallway. And so we'll be gathering 2 numbers from each person in this room, their shoe size and the amount of steps it takes to walk from here to there, basically. We went down the hallway. Then graph the data as a set of ordered pairs, and we're going to create right here at the bottom something called a scatter plot. So this will be real easy because only 7 people told me. So somebody told me that they have a shoe size of 8 and 56 steps. And then I had a shoe size of 13 and 61 steps. A shoe size of 5 and 73 steps to get to the window. Here we go, 8.5 and 72. Size 10 and 64 steps. That's a 10 right there. That's a 0, sorry. Another person was size 10 that took 72 steps. I think that's pretty interesting. 4.5 as a shoe size, 75 steps. And then someone with size 13 shoes, 53 steps. Okay, got all kinds of room here, but nobody else put anything on canvas, so that's how we get people. So I'm going to make a scatter plot. Now what happens with the scatter plot is you have 2 variables. So what I'm going to suggest here is if one of them kind of explains the other one, I think this is our explanatory variable, shoe size, and this is the response variable, steps. Stands to reason that if you have much bigger feet, you're probably a taller person, and your step goes further, so you need less steps, right? So you always take the explanatory variable and put it on the horizontal axis. So we'll put shoe size here. And then you the response variable then, of course, goes here. So number of steps. Okay, so I'm going to scale my axis with the large amount of data that I have. The smallest shoe size I have here is a 4.5, and the largest I have is a 13. So I'm going to go from 4, let's see if I can do it this way, 5, 6, 7, 8, 9, 10, 11, 12, 13. That worked out pretty good. 5, 6, 7, 8, 9, 10, 11, 12, and 13. And then how many steps do we have here? The smallest, it was around 53, it looks like, and the biggest was 75. So I got to go 50 to 75. So there's my 50. I'll just go like this, 60, 70, and 80. So at the top, I'm going to say shoe size versus steps. And then you treat this like an X and this like a Y. This is an X and a Y, so we have X, Y points basically. Here's what I want you to do. Plot all 8 of those points. Do that now.